Hi everyone, my name is Vinayak Hegde and I'm the Principal AI Advocate at Microsoft. Welcome to this series. This is the fourth in the series of the AI Genius series, which started on 28th of January this year. And this will run up to 4th March 2025. And after that, we will have a project which you can do hands-on. As we continue in the series, we'll have more details for you. So just reviewing what we have gone through so far. So as I said, this is the fourth in the series. The first was on 28th, exploring cutting edge models, LLM, SLMs, and more. Then we had a session on RAGs. Then we had one of the first sessions on agents, and then I'm going to follow up with agents. And then on 25th and 4th, we'll have more on the cloud native infra and Copilot for Azure for making sure the deployment. So we're covering the different aspects of building AI applications, and hope you will find this useful. You should have if you scan the QR code on my screen, you should be able to look at the series, and you should be able to find the older episodes that are there on YouTube from the bottom of the page for the past episodes. And even when this presentation is over, you will find this recorded episode in the page for building intelligent multi-agent systems. So with that, let me just get started. So as I said, my name is Vinayak Hegde, and today I'm going to talk about building intelligent multi-agent systems. So let's quickly go to the agenda. Just give me a second. So what we are going to do, just setting the scene for the next maybe 45 to 50 minutes, after which we'll take questions. We'll do an introduction to AI agents. We'll talk about evolution of AI architecture. We'll look at some agent use cases. We'll talk about building agents, and then we'll do a sales assistant demo use case. And then I'll show you a multi-agent architecture and also give you the resources to actually start building on those. So without further ado, let's start with the first chapter, which is understanding AI agents. So there's a lot of buzz about AI agents lately, and it is very easy to get lost in the hype without having a good foundation of what exactly are AI agents. In this presentation, we are going to help you get a better understanding of AI agents by defining them, looking at what came before them, what use cases can you apply for AI agents, and lastly, the basics of building an AI agent. So first, let's see what is an AI agent. So if I were to define an AI agent, there are a few things that I would look at. So the AI agent is an LLM-based application, which is semi-autonomous software entity leveraging large language models to perform specific tasks um, uh, through natural language interaction. There is also three parts to it. First, to create a plan, then retrieve the context, and then finally perform some action. So we call these applications autonomous, semi-autonomous, because the key part of an AI agent is that the LLM both creates a plan and performs an action, and the action is based on the request from a human user. So it is important to think of this application as software, as many of these software-based practices around testing, monitoring, security, and deployment still apply here. AI agent application perform an action. So this makes them different from other types of AI and generative AI applications that you may have used or built before. So we'll look at the evolution of different AI architectures before we fully dive into AI agents. So give you a quick recap of what we've covered in this series, and also do you kind of compare and contrast agents and their architectures and how they are different. Cool. So this is a typical chatbot application, as you might have played around with. So if you have been working with AI and LLMs, you would probably have used chatbot application in some form. So this is the first type of interaction that AI model that users have experienced. In this application, a user can ask a query. In this case, about a vacation day, and the user has been trained on a knowledge base of question and answer pairs. And based on the question and the intent of the user, the LLM can identify a proper appropriate response, or given based on the system prompt, it can respond in a way when an appropriate response cannot be located, right? So if you ask it maybe any kind of random question, maybe about something related to, say, maybe your company leaves, it does not have that information. So it will give you an kind of canned answer which it can't do. So it has some limitations. Knowledge is limited to connected data sources. Chatbots are unable to perform any action, and they have limited scope in response, right? The knowledge obviously also limited to the knowledge base that they have trained on. So with this, there was another evolution. Without RAG, there were generative AI applications, and we'll talk about RAG in a bit. So instead of using traditional ML with access to knowledge of base of Q&A pairs, these LLMs provide a chat experience to users. LLMs have a great ability to interpret and natural language and respond in natural language. That is what makes them different. LLMs are also trained on large amounts of data, so they have high ability to answer any kind of general knowledge question. So the ability has its limits. The LLM does not have access to any relevant data of the user outside of the existing context of the conversation, right? So if you give it any extra context that you have, it's limited to that, and then it uses this kind of world knowledge upon which it has been trained on. So it can only answer questions that are within the scope of its training data without outside tools or data sources. So given this information outside of this data, ungrounded LLM has high probability of the model to fabricate responses, what we call as hallucinations, right? So there are certain limitations to kind of wrap up. Response is not grounded in relevant user data to the user. Responses are limited to the training data of the model, and high probability of the model to fabricate answer. So to get over this kind of limitations, we had a generative AI application with RAG. So RAG has certain additional advantages. They use a LLM model which has access to external knowledge databases. It enables an LLM to provide a personalized and grounded response to user. With this architecture, LLM can provide personalized and grounded responses. It should be able to identify a employee ID through user authentication and with search an employee database to verify their vacation results. So again, it's tied to the user and the user's information based on what they provide. So we're giving extra context here. So RAG, or retrieval augmented generation, has three parts. Retrieval, when you retrieve relevant context, augment with whatever context you have and whatever is retrieved, and finally use the generation abilities of the LLM to actually produce a response. So RAG is an incredibly powerful response that comes with some limitations. While the LLM might be able to access multiple data sources or its training data based on what the query is. This activity is best suited for retrieval scenarios where there is an expectations of what user might request, and where the data lives very where the data lives respond to the question. So the LLM does not perform any tasks based on the user's request. So it basically retrieves from the knowledge base using the search API and then grounds that. So there are lesser hallucination. So it provides relevant response for the users, but the model is limited to data sources. It works well for information retrieval scenarios, but not action-based ones. So it can't take any action. It's only retrieval. And questions outside of the planned scope maybe not be efficiently answered because, again, it's restricted by the knowledge base. So let's now look at agents and how they are different, right? So agents can perform a complex set of tasks that might require multiple tools and data sources to complete. This makes them very suitable when the user's requests are more diverse, right? So even when the scope is larger, it can still interpret and call the right tool in this case. So we have examples of this further down in the presentation, and we'll see how that it creates. So in this particular example, before performing an action based on the user input, it creates a plan, as we've seen in the initial slides, of how to complete the task. It first searches the employee database to identify how many vacation days are available for the user, performing the action of requesting vacation days through an HR system, and then finally sending an Outlook invite to the user's email. So through prompt engineering and using an AI agent framework, application builders define the role of the agent, the business process, and the tools it has access to in order to complete the task. So the tool calling is something that is different specifically, and actions it can take based on the tools. And we'll talk about all of these aspects as we go further. So what are the benefits? Agents can perform complex tasks. Agents can plan out actions based on user input and intent. Agents can use knowledge databases and define business processes, and also access different tools to carry out the action. So that is something that is different. This can be extended to multiple agents which can work in conjunction with each other. And we'll see an architecture on the screen similar to this. This builds upon a single agent application by using multiple agents, each of which has a specific role or task that they can complete. So a specialized agent, and each agent can possibly use different prompts, different LLMs, which are specialized, fine-tuned. They can use different knowledge sources. So all of these can be done. So each agent can be either codependent or independent in terms. So it depends on how you want to plan your architecture. So instead of having the user manually select what agents are used, the agents coordinate amongst themselves to complete the task. This can be done using orchestration frameworks that allow users to define the capabilities of different agents, and then the agents create group chats among themselves where the coordination happens. So the advantage of this is that agents can have specific system messages. As I said before, they will instruct them on their rule versus the risk of overloading prompts by using a single agent. So again, you have specialized agents, and we'll see examples of this as we go on. This allows developers to control tool and data access better, because each agent can have access to either a specific set of tools and a specific set of data which it is designed for, right? So as you have seen in this particular example, you have a data agent and a HR agent and a booking agent, and each of them does like very specific tasks, and they cooperate between themselves to access different knowledge sources and different actions, right? So what are the benefits compared to say single agent? Multiple agents can perform specific assigned tasks. Agents are not overloaded with complex prompts. Agents only have access to specific tools and specific data that that particular agent which has been assigned that role and task. So with this, let's look at some of the agent AI use cases. So some of the agent UI use cases that we've seen where we require, planning and then tool selection and eventually doing the responses. One example could be travel booking and expense management. So it can assist employees in booking business trip. It could integrate with TripAdvisor, Outlook, SharePoint, each of these via different APIs. It could book via Teams, email, or chat. You could also use OCR to gather receipts so that the expense can be done very easily. And it can automate expense and report tracking based on the user's hierarchy. Similarly, you can. We just saw an example of HR related example, right? Where you can ask for a vacation days. Employee onboarding can be done using personalized onboarding assistant has using LLMs grounded in HR data and SharePoint, providing relevant training material so that the newly joined person can actually get up to speed, and they can also schedule it, any kind of software accounts as well as any orientations that are needed for any software that is used for the role, right? And at the same time, you can have a tracking mechanism to figure out, if the onboarding has completed, and you might have a certain score based on what is absolutely essential, what is nice to have, and what is like recommended. Similarly, there are use cases in data analytics and reporting, and also personalized customer support. When it comes to data analytics and reporting, we will go deeper into an example which actually connects to a data warehouse um, or a database to actually pull out different examples and graphs. So this is the example that we'll go to. But before we go that, let's talk about how do we actually build agents. So looked at how agents are different. What are use cases? Now we'll talk about building agents. So what are the considerations when you're building agents? The first one is knowledge. Will the AI agent have access to the right knowledge and data source in order for it to complete the task requested by users? Um, Second, as I said, agents can do actions. So once the agent has the data, what tools does it need in access to order? To what tools does it have access in order to complete the request action of the user? When it comes to security, how do you make sure that the AI agent only has access to the right amount of data at the access level of tools, right? So we typically talk about AAA, authentication, authorization, and access control. So we have to look at what is the user and the agent who acts on behalf of the user, what access do they have to at the particular level, right? So for example, when you look at say expense tracking, just using the HR example, as a manager might have access to the expenses of his subordinates but not to the access of their superiors, right? Similarly, a CFO would have access to maybe the expense management of all the users that are there in the particular organization, right? So depending on where you are in the hierarchy, you will have access to different sets of data. And finally, evaluations. How do you evaluate how well an AI agent is completing the task, right? This is absolutely essential when it comes to quality control. So we'll just blow it up a little bit to look at some of the things that we can use when it comes to the AI agent consideration, right? Like when it comes to knowledge, we can use Microsoft Fabric. We can ground it using Bing search, which is like using a web index. You can use your own data. You can use local file, or you can use a file dump on Azure Blob. That's possible. When it comes to actions, you can use logic apps, OpenAI tools. You can write custom functions. You can write Azure functions. Uh, when it comes to security, right, restricting the access to data in order to keep data and users secure, and so that it doesn't go beyond the agent doesn't go beyond the remit. You can apply content filters on both input and output. Make sure that the data is stored in a secure location, and make sure that the user authentication performed correctly in the cases where the agent needs to perform on behalf of the user. And eventually, when you look at evaluation, we probably look at it holistically when we look at observability, right? So as these agents perform action without the user's intervention, and then there can be some user intervention, maybe for example, giving consent, or before actually maybe charging a credit card for any bookings, that can be done. But generally, most of the actions which are maybe low risk, or which are vetted, or we have confidence in the agent, can be performed by them. But we need to know how these actions are performed. There needs to be tracing and evaluation, tracing and monitoring their actions, and then this visibility is very critical. So when building an AI agent application, it's important to evaluate the performance of different maybe prompts, different orchestrations, as well as different models, right? So evaluation is like super important, especially as you change models, try different models. So now let's maybe look at a demo. We'll use a use case of an e-commerce selling equipment, and you want to analyze some sales data. And we have this company, hiking company called Contoso, that is outdoor company, and it has kind of created some data. I will share the URL where you can recreate this particular demo for yourselves, and actually use that as a starting point to build your application also. So we have want to reimagine the UX which Gen AI that our sales team can use. So I'm just going to demo the Contoso sales agent, and it has a read-only database. We have simplified the data structures to be query friendly. It uses multiple different things. It uses natural language processing through an LLM. It uses dynamic SQL generation. It also does tool calling, which we'll look at in a bit. It does orchestration very well, and it integrates with various data sources. We have defined how we want the app to behave with the meta prompt and metadata. We also provided the LLM knowledge of the series of tools that it can integrate with existing data sources to provide context to the LLM, right? So we'll look at team calling just as we finish the demo. But essentially, what happens in tool calling is based on the intent, it will figure out what tools to use, whether it has to do a query, whether it has to access a database, and eventually it will kind of figure out how it's going to do that part as well. Cool. So let me go into the demo. Uh, so this is the application that I have, and um, I'm going to ask it a series of questions. So I've set up this. I've given the context to the application. So I'll do the demo, and then we'll go deep dive a little bit into the architecture, right? So let me just start off with the demo. Just give me a sec. Cool. So let me just start off by asking for help. And as you can see, it is saying, hey, I'm here to assist you with any queries related to Contoso sales data. And it's giving me an example of, what are the example queries. So feel free to ask any questions. Now, it is possible that, maybe I'm not like very comfortable with English, and, I want to maybe localize the content. So I can even ask it things like help in Hindi. So here I'm taking the same help, and LLM is actually figuring that, okay, it has to translate the context into Hindi. So Hindi is a language that is very commonly spoken in large parts of India. And if I don't understand English very well, or if I need additional context, you can see that it answers it in a different script and also translates that, right? So the LLM has the capability to do that. So next, what I'm going to do is, I want to explore, how the sales were. So I'm going to ask it to create like I have already given this data to the LLM in the context. So I'm going to create a vivid pie chart of the sales by region. So here, you've seen you've seen the agent actually give you help and give examples of queries. It have also seen that it can translate that help or any kind of questioning into that specific language. Now we are going to see if it can do charting for us. So what you should do is that it should be able to select the right tool, and once it creates the right tool, it should be able to create like an SQL query and be able to give you that question, right? So here it has generated a pie chart illustrating the sales per region for Contoso, and each segment represents a proportion of total revenue that has been contributed by each region. So if you have any more questions, or assistant is asking that we can ask more questions. So here now I'm going to show you some things behind the scene, and we'll talk a little bit about those as we go further down, right? So if you see, it has used the SQL function, right? I've given it a set of questions. Obviously, it has done translate before. It is also has access to the code interpreter. So it has now generated this chart, as you can see on the screen, uh, by first writing an SQL query and then taking that SQL query, putting it into a format which the LLM or the agent can understand, and then it's generating the code, and eventually you can see that plt.show, it's generating the pie chart that you can see, right? So it has used two tools. First, it has figured out that, hey, I need to ask a database, I need to generate a query based on the natural language question that I asked. It has generated the SQL query, got the data, generated the code, and finally it has generated this pie chart and then displayed that to us. So let me also maybe add, maybe uploading some data. So let me just, I have this data sheet. I can just show you this data sheet. 1 second. Let me just pull up the data sheet for you so you can see what it contains. So you can see that it contains, the expanded product sheet. It contains information about the product, camping, hiking information. So I'm going to take this data sheet. Let me go back to the, let me go back. So I have attached this Contoso sheet and I've shown you the contents. Next, I'm going to ask it, specific questions about what is there in the file. So I'm going to ask it, what beginner-friendly tents can Contoso sell? And let's see, how it kind of modifies the answer based on, the file. So it is uploading the file now. Once it has uploaded the file and processed it, it will figure out based on its own knowledge, based on the question, and based on the contents of the file, uh, any question that it has, right? So we can give it additional context based on any information we have. And as you saw from the particular PDF, it had access to these two questions. So it has taken that and it has now created it in a format that you can understand, and it is also giving you the references to those specific parts of the PDF file that you uploaded, to be able to kind of reference it. So you can go back and verify that these answers were right. So I can take this particular line of question and then also be able to create like a Excel or a table based on what sales have. So I looked at the sales by region, and I have now have given it a brief description about each tent. So let me combine these two, and it should be able to then now select the right tool and be able to give you this information, right? So as you can see, it is actually generating the region, the total revenue, and it's also giving you the sales description based on what you have done. And again, it has given me all of the references that it is there, right? So this is like excellent. And each of these times, as you can see, it is actually telling you what action it has taken, so you can actually verify that what function it has used. For example, it has again used SQL, and it's actually showing us how it has used SQL, and here it's actually telling us how it has used the PDF file. So now I might want to export this. So what I can do is, hey, can I create an Excel file and maybe view it? So let's try that, how whether it can do. So I have done input, I have done referencing, and now I'm going to do an output. So it's again using code interpreter here, and it will generate an Excel file based on the data that we are given, and then we should be able to open that Excel file. So if I open this Excel file, you can see that whatever information we just saw, so whatever information we just saw, it's able to take that by region, the revenue, and the description, and it has created an Excel which I can do. So this is, you have seen the capabilities. It has done tool selection, it has then generated the queries, and all of this has happened very efficiently. So let's go back and see how all of this is kind of put together. Let's take a behind the scenes look. um, One of the main things that it has used is different kind of frameworks for function calling can be used, such as LangGraph, LangChain, AutoGen, semantic kernel, crew.ai. So that leaves us developers with a lot of complexity, and also let's look at function calling. um, so the function calling is the capability of LLMs to take in user-defined function as inputs and then generate structured output, right? So, for example, we had given it SQL, we had given it function to create like Excel files and a whole bunch of things, right? Like you could also use code interpreter to generate code, which it used to actually generate code and then also generate the graph. Uh, so, um, so there are certain models in OpenAI that support function calling. So you have to provide a definition of function call. Then the LLM, based on your conversation, figures out which particular function can get you structured output, and then it's up to your app to decide what to do with the structured data. In this case, you can execute an SQL query and return data as context to the model. So let's take an example of this. So you are a sales analysis agent for Contoso, and you get all of the sales data from this app using the functions provided. This is the instruction that I'm reading out, and use the database, and then the metadata when writing SQL queries, and it is generating that function. And we saw live example of this when you saw the SQL query that it has generated. Next, you give it the context for the user, and based on this context instruction and the function, it generates this query, right? So it has generated this query called async fetch sales data using SQLite query, and you can see it has generated this query saying select revenue from sales where month equal to 4 and year equal to 2023. So it is basically pulling data for the April 2023 based on the questions that it has. So the process is actually pretty simple. First you do the tool selection, look at the instruction metadata, look at the intent of the user, combine them, pass that to the LLM. The LLM will then generate, you take this information and generate either SQL query or code or whatever things that are needed that need to be executed by you for that particular output. And eventually, once you run the output, you get the response, and the response was a pie chart or an Excel file or any data that you did. So you can integrate with like n number of data sources, n number of APIs using this. So let's look at the solution architecture, how it is kind of stacked. So I have used chainlit, and then I'm used query function to actually interact, so that whatever is the user intent, the user conversation that is used, that is then passed on to the Azure AI agent, which has instructions. We just saw example of instructions, and there are models associated. For example, GPT-4o or Llama or any of the other models you can use for that. And then you finally have actions, which is the tool. You have used code interpreter, you have used function calling, we use file search, and then we have used grounding with Bing search. So there are multiple different functions that can be combined, and this is how it is kind of stacked. And uh, the the request goes from top to bottom and then back again as the response is generated. So how does the agent work? So I gave it as a user, I gave it a query, tell me the total sales by region, and show as a colorful pie chart. Uh, Here is your sales data as a chart. It was the answer, and then I got the chart. But what was happening in the backend was natural language processing, dynamic SQL generation, which we just saw, orchestration between the tool calling and making sure that the tool got the outputs from the LLM and the response are funneled back. So this entire process was orchestrated, and then there was also integration for each of the agents with the different knowledge sources. Right. In this particular case, the knowledge source was the SQLite framework as SQLite database, as well as the when we uploaded the file, we added the information using the PDF upload function. And then we use like pre-built or custom tools to automate the process. We also looked at the different kind of models that are there in the backend. So let's see in a even more detailed view, how does the agent AI agent service work in action? The step one is create an agent, create a thread, run the agent, check the run status, and finally display the agent's response. In this particular case, we created a Contoso sales agent, and the instructions given were your advanced sales analysis agent for Contoso, specializing in assisting users. Then we chose the model. Then we looked at the data. In this particular case, it was SQLite, and then we are given it a list of tools which are optional. We are given it file search, code interpreter, function calling, Bing search, access to Microsoft SharePoint, Fabric, Logic apps, query function. So again, depending on what is the intent of the user, it has access to all of these different tools that it can call. So this was the user's message. In run one, the function calling tool said, hey, you need to query SQLite, generated a query, took the output and formatted in a way that we could understand, right? So if you go back and if you see the application, it has not only actually given you the answer. It has not just dumped the answer. It has created, in this particular case, a table. In this particular case, it has given you a pie chart. So it has actually not just dumped the output to you, but it has actually structured the output in a best way that you can understand, right? So structuring the output is also super kind of important, so that the information can be digested very easily. Then we had the second question, show us as a pie chart. It ran a code interpreter, which we just saw. It created a pie chart, created a message, and the output in this particular case was an image which was sent back, right? So again, like you can see that this interaction keeps on continuing. So as I said, I mentioned agent AI service in the background. So let's talk a little bit about the Azure AI agent service quickly. So we need to look at how do we actually build this AI agent to automate the process that we looked at in the last slide. So why is the Azure AI agent service unique, or I would say so useful? Because it allows you to securely build, deploy, and scale AI agents with ease. It makes it easy to do rapid deployment and automation. It has extensive data connections, so you can expose a lot of different tools. You don't have to write all of those tools for yourself. It's very flexible with model selection based on what you're comfortable with, what your particular use case wants, and most importantly, it has enterprise grade security. So it integrates with any kind of enterprise grade controls that you need to have. So it's in public preview right now, and it's available through the new Azure AI Foundry SDK. So again, kind of summarizing what we said so far, large language models have defined instructions and tools, services and functions that extend the agent's agility are inherent tools, and we saw examples of that. In specifically for the Azure AI agent service, we looked at threads, right, which manages and truncates messages. Each of these work in conjunction, and then eventually you have the run, which activates the agent to perform tasks based on the thread context and configured tools. So threads are also used to store messages between the agent and the users. As the users reply, you can append messages to the thread, so there is context. To manage the conversation length, messages are automatically truncated to fill the model's context length. Moving on to runs. Runs are where the agents are activated to perform the task. As we have seen, this activation takes place based on the message content in the thread. The actions are also completed by the selection of the agent by using the appropriate tool that relates to the request, right? So we looked at a single agent, we looked at a demo, but when we talked about the presentation, we were talking about how do we do this for multi-agent patterns, right? So let's see, how do we extend this from one agent to multi-agent pattern. So multi-agent systems consists of multiple intelligent agents that can interact. Each of those agents, as you've seen in earlier slides, interact and collaborate to solve complex tasks. They can share information, achieve goals autonomously or semi-autonomously, and they do this by kind of figuring out which agent needs to be activated at what point. So you can have different kinds of architecture. For example, you can have a command and control, which you have an overseer agent or overseer uh, uh, command where it actually controls which agents need to be evoked. Or you can have it very fluid, where the LLM, based on the user's intent, can choose what agents need to be sequenced in one pattern. So the sequence can be dynamic, or it can be partially static, or semi dynamic, based on how you want to kind of structure and what kind of use case makes sense for you. So I won't be demoing this, but I will actually talk about a creative writing copilot, which you can actually, I'll give you the links to that. So if you want to kind of replicate it, I'll give you access to the repository, which you can clone and then try it out on a subscription. So this is something that we built. If you have come to any of the AI tools, or you've seen some of our earlier presentation, we use the example a lot. It's called Creative Contoso Creative Writer. On the left hand side, you have the research. So you give it what kind of things it should find, and then you give it a prompt. Then you ask it what kind of products that need to be done, and eventually you give it some kind of prompt with the length to actually write a research article. And then it goes and it starts those agents. It first does research, then figures out what products are to be used, and then eventually comments all of this research and background and context to create an article that can be pushed put on a website, or in some kind of an article. And I'm showing here the debug view. So it has started a research agent, and the research agent is actually going and pulling information from the Bing Web Index. So quickly, maybe we'll talk about before we end this presentation and take questions. We'll take a look at how this multi-agent scenario works. So you take this user input, as you've seen. You validate it using Azure Managed Identity. We have built this as a container app, and all of the monitoring happens using Azure Monitor. So you can actually debug. And actually, if you look at Azure Monitor, you will see that we can look at it like step by step about what is happening. So every specific user query can be traced. In production, maybe you won't want to do every stage, but you want to do maybe at least for a percentage, so you can have some kind of a quality control when you are actually using the agent. And as I said, as I go back here, just a sec. Yeah, there are three different I would say agents that are working in conjunction: the research, the product, and then the writing assignment. And here you can see that you have the research. It uses the Azure OpenAI service. It uses the Bing search. It uses the Azure AI search. The writer agent takes all of this research that has been generated uh, by the research agent, writes an article. Once it has written that article, that needs to be vetted, right? So you might have some kind of quality control, and you can codify that in terms of the user. So in terms of what kind of guidelines you have for writing, right? For example, everything needs to have references. Maybe you cannot use certain kind of words. Maybe it could be that you need a certain tone, or first person, third person uh, um, kind of narrative. So the editor will actually take whatever prompts you are given to it and give it to the right and check whatever is output of the writer agent. If it feels it is okay, it will say, hey, it looks fine, and it will pass on the response to you. Or it will go back to the writer agent and say, hey, this doesn't kind of meet the quality standard, so you need to regenerate it, right? So this will iteratively go on until you get a response that the editor is happy with. Again, while I'm not demoing this example, you can recreate this example very easily by using the URL at the bottom of the screen. github.com/azure samples slash contours creative writer. It has all of the details that you require for setup. You can try it on your own subscription, and you can see how the different agents are spun up, how they perform the different tasks, what is the output, tweak all of the code to see how it affects the output. You can use different models, you can change the prompts, you can play around with it, and then once and become really comfortable with this multi-agent scenario. So it's a very fairly comprehensive example that you can take a look at. So with that, I have kind of finished my presentation, and I will look at some of the takeaways to summarize what we have learned so far, and then give you access to some of the resources that you can do, and maybe towards the end, we can maybe take some questions as well. Cool. So let's look at some kind of takeaways about agents, Azure Agent AI Service. So how do you kind of build an agent, right? First, define and identify your use cases where agents can be effective. Remember what we said at the beginning, right? Agent needs to perform an action, and that is how it's different from a chatbot or a RAG scenario, which only look at retrieval. And again, they have been ring fenced to do that itself. They cannot perform any actions, but the agent can perform actions. You can take it to the next level with the Azure Agent AI service, which provides a lot of context and scaffolding and also tooling, ready-made tooling to help you do function calling, code generation, file search, and more. And we saw examples of this in both the Contoso Creative Writer as well as the sales agent that we just demoed. Then you can use different kinds of frameworks to kind of manage the implementation. You can use Autogen or Autogen Magnetic, which is the newest version that you have. You can use the Azure AI agent service. There are also functionality within semantic kernel. Semantic kernel is, by the way, our open source orchestration tool, which does a lot more. So you can actually use that in your particular agent. You can also use various kinds of UI tools. So the last um, demo that I built was built using chain lead, but the other tools also we have used, like for example, there's Replit that you can use to build a UI very quickly, and this kind of frameworks have made it really easy to interact with different agents. So you don't even need to be like, if you're just building like a simple interface, don't even need to know a lot of front end coding, right? So this actually make it really really easy for you to do that. So this is, I would say, the next steps, and then let's quickly go to the resources. So we have the Azure AI Discord. You can join this, and if you have any questions, further questions on agents or any of the series that we have done so far, please join the Discord channel, and we should be able to answer any questions for you. We have just launched, by the way, the AI agent for beginners. So I highly recommend that you look at AI agent for beginners. So the link is on the screen. You can use this short URL to train yourselves on the different aspects of building agents. It has much more detail than what we have been able to cover in this 45 minutes, roughly 45 minutes of presentation. If you want to know about generative AI, and I would, for beginners, it is a little bit of a misnomer because it's not just for beginners. Even if you have some amount of experience, I'm very sure when you go to the generative AI for beginners, you'll see fairly detailed description of the different aspects of building AI apps. We covered a bit of this at the beginning of the presentation as we looked at RAG, we looked at chatbots, but this goes into each of those aspects of building in much deeper. There are, as at last count, about 24 lessons, and me and my team actually continuously update this. So this is maybe like the one-stop resource that you can use um, for getting yourself upskilled. All of the content that I've talked about and a lot more for building AI applications is there on the Build AI Tour repo. You can use a short URL aka ms/ai2/repos to actually access it. And all of the code, the slide deck that I used for building this demo can be seen. This is the Build AI Tour has links to the last one as well as any other repos that you might require to. So I highly encourage the Azure AI Discord for asking questions, AI agents and generative AI for beginners, to actually skill yourself up and then actually practice this using the Build AI Tour content, which has the slide decks, the repos, and everything else that you might require to get started. With that, I would want any feedback. So, as I said, this this series continuing. So if you have, I would leave this on the screen. So any kind of feedback that you give for us, what you like, what you didn't like, what more would you want, if you can tell us, I think it will help us improve our sessions. And we are very thankful if you can actually fill out this feedback, because we have this series, but based on your feedback, we'll also kind of localize this series. We'll also add maybe other sessions which maybe probably may not have been covered, because as the industry moves, we want this feedback to be able to make the series better as well as make it more relevant for you. And last but not the least, if you have missed out on the other sessions, I would suggest you scan again, and it will take you to the AI Genius series page to actually look at the other sessions on the series. You can look at the past videos as well, which me and my colleagues have put together. So if you want to look at cutting edge LLMs or the Azure agent service in more detail, Kinfei, my colleague, has done that before. Anthony Shaw has talked about RAG in much more detail in the second part of the series, and the further part in the series, we are talking about deployment and other aspects as well. So you can go and look at the specific parts in the series. So I'll put on the series page once again. Just give me a sec. This is the same QR code that you can do, but it actually can see what has kind of happened and what we can do. So if there are any questions, you can put them in the chat, and then we should be able to take any questions that we have. So Michael, do we have any questions? Maybe we have time for maybe a few questions. We can end with any questions they have. So Mohammed Afan is asking which framework is best and preferred for multi-agent development. Um, Again, there is no, I would say, one framework. This is a fast evolving space, so there's no one framework that is useful. As I said, there are multiple tools. There's semantic kernel that we talked about. There is Clue.ai. LangGraph is a very also very popular. So again, I have seen in the field different people use and get variant sets of success, as this framework is also quite fast evolving. So I won't say there is like one recommended framework, like just like I would say, when building like a website, there isn't one framework. Some people prefer a static website, some people prefer Python, some people prefer Ruby based frameworks like ROR. So it depends on use case. I can't recommend one framework, but amongst what I've used, I would say look at something like the Azure Agent AI service uh, with semantic kernel or LangGraph. I think these are the two or three ones I would say which are very actively developed and which we can use to build any kind of agent. So yeah. So towards spirituality asks, how do I register new agents and provide channels for knowledge base and associate actions? Can you give me more information about this configuration? Yes. So this actually is there in a YAML kind of manifest where you have multiple different things where you can register a new agent. It is there in the repository. So all of the code that I've talked about is there in the repository. Hello. Yeah. So okay, I'm back in the new repository. So it has different sets of connectors. It has a list of tools. It has the sample configuration which you can actually use, and then you can associate actions with those. So basically, uh, you give a short example of how what the tool can do. For example, you can say for SQL generation, this tool can be used to connect to the database and generate SQL queries, and the LLM will actually figure out whenever you're asking a specific query. Like I asked in the case of sales by region, that it needs that database. So any kind of data that is structured data can come from that. So you can actually provide the listing of the tools. It contains interestingly, the description of the tool is in natural language format, and the more tighter and the better it is, the more the chance that tool will be picked. Also, when you one more kind of advice when you kind of build a tooling is try to make sure that there's no, I would say, overlap, or like as less overlap as possible between the descriptions of the tools So then it makes it easier for the LLMs to be able to choose the right tool and do it. For example, if there are two or three providers, say for SQL, it might, based on your query, it might choose one of those, and maybe those connect to different kind of databases and have different prompts. So it is possible that you might get slightly different output based on the query that you ask. So you don't want that. So make sure that when you have the associated action and you give this information about the tool to the LLM in human language format, you make sure that, try to make sure that there is very less overlap between the tools. So a good example would be, you have one tool to do the query, another tool to do the interpret the code, another tool to maybe do the graphing, another tool to maybe send an email. Uh, so each purpose is distinct. So if I ask it, say, hey, can you tell me what is the sales data for a particular region, and email it to me, it knows that, hey, I need to first, generate the SQL query, connect to the database, get the data, then it will sequence the other tool which is related to generating the pie chart, and finally it will take all of this output and email it to me. Uh, or in the case I've shown it that downloaded an Excel file as well. Good question. I think actually, Kalyan, I addressed this in the presentation as well. For quickly building the UI for multi-agent or RAG application, are there any tools for doing that? Yes, there are multiple tools, and you can search the internet for like lots of different examples. But the two that I've used very successfully are Replit and Chainlit. This make it really easy to build like a chat-like interface, which I just showed you. So it doesn't have to be a chat interface. It is basically interface which will give you the context, collect all of the context and send it back. So as the conversation goes, and also provide some kind of connection with the LLM to be able to push that and do some amount of tool calling. So Chainlit and Replit are the tools that I have used very successfully, but there are lots of others. As I said, with AI frameworks as well, the UI frameworks is also uh, being actually done. So this demo which I just did, let me just go back to the demo. This was done using Chainlit, but I have used Replit as well. Um, so it actually, all of these things, right? Like, I can change it to dark mode, I can use login. I can see this like search bar and look at the past kind of experience. All of this functionality, I didn't have to do anything. It provides things like, I can attach files. uh, it makes all of these things easy. It's provided right out of the box for it, right? And then I can here close the sidebar. So all of this functionality that I'm showing to you is done like super easily using is done easily done using Chainlit. Yeah, thank you for audio session, and we look forward to actually seeing you next week. You have the badge to display on your social, so you can scan the QR code and download the badge, and then you can post it to LinkedIn and let us know your feedback in the social media posts as well, and any other feedback as well. Thank you so much.